We're going to be examining the ideas within a paper called The Right to be Remembered. It addresses a rather critical question for our era. As large language models increasingly become our primary interface for information, how do we make sure they don't inadvertently erase parts of our collective digital memory? The work proposes a new framework for ensuring our digital history is not only preserved, but also maximally truthful. The central issue here begins with a shift in how we access information. You see, a traditional search engine gives you a list of sources, a range of alternatives to compare. A large language model, an LLM, on the other hand, frequently provides a single, synthesized response that carries an air of authority. This model concentrates significant power, shaping what is collectively remembered and, just as importantly, what is not.
Now, when any single system holds that much sway over information curation, it introduces a systemic risk. We face the potential for a gradual erasure of certain narratives, a slow reshaping of our collective memory. As these AI models become the default lens through which we view knowledge, their inherent biases and omissions could begin to permanently alter the historical record.
So, the fundamental transformation is from information retrieval to knowledge synthesis. A search engine points you to a variety of documents, leaving the interpretive work to you. An LLM, by contrast, digests vast quantities of text and then generates a novel response. In doing so, it often collapses multiple viewpoints into a single, seamless answer, which can obscure the fact that perspectives from less documented or marginalized groups may have been left out of the synthesis entirely.
So how does this AI-driven forgetting actually occur? Let's examine the specific dynamics at play. It's important to recognize that these are not isolated errors, but rather systemic issues inherent in our current digital infrastructure and in the architecture of LLMs themselves.
This process of digital forgetting is propelled by several key mechanisms. First, we have link rot, which is the simple fact that online content is ephemeral. Studies indicate that a substantial portion of web links cease to function over time. Second is dataset bias. If information isn't digitized, indexed, and made accessible, then for an LLM, it essentially does not exist. Third is algorithmic omission. Because these models are statistical in nature, they tend to amplify the most frequent narratives found in their training data, which inherently marginalizes less common perspectives. And finally, there is corporate filtering. The moderation and alignment policies of vendors can result in the suppression of legitimate, albeit potentially controversial, information. To grasp the potential scale of this data loss, consider this finding. A 2017 analysis of nearly 500,000 articles in the biomedical literature found that only 40.48% were assigned a permanent digital object identifier, or DOI. Without such persistent identifiers, the majority of this scientific knowledge is susceptible to link rot, which means it could very easily be omitted from the knowledge base of future AI systems. Furthermore, this problem of data vulnerability is not distributed evenly. The same study revealed significant geographic disparities. For example, while roughly half of the publications from the US and UK had stable DOIs, the corresponding figure for nations like Russia and Ukraine was under 2%. The consequence of this is quite severe. Entire bodies of scientific research from certain regions become far less visible to AI, introducing a profound bias into the scientific record that it can process.
In response to these dynamics of digital forgetting, the paper introduces a new conceptual framework. This is articulated as the right to be remembered, and it's designed specifically to counteract the systemic erasure of human contributions within our increasingly AI-driven digital memory.
So what is this right to be remembered, or RTBR? Fundamentally, it's a normative claim, an ethical position. It argues that human contributions, be they scientific, cultural, or social, ought to be preserved and kept accessible within the very digital systems that are now becoming the arbiters of knowledge. This reframes the preservation of digital memory not as a technical afterthought, but as a matter of justice. The justification for such a right is built on 4 pillars. First, it serves epistemic justice by pushing back against the systematic silencing of marginalized voices. Second, it advances cultural preservation by helping to safeguard a more diverse and representative archive of human experience. Third, it acts as a foundation for progress, which relies on access to prior knowledge. And finally, it treats our collective memory as a public good, something essential for accountability and societal continuity. Now, to implement a right like this, you need a technical commitment to what the paper describes as maximal truthfulness. This concept extends beyond simple fact-checking of outputs. It involves interrogating the internal states of the models themselves to assess the reliability of the information they generate. How might this work from a technical standpoint? Recent investigations into the internal geometry of LLMs offer a compelling possibility. Probing studies have managed to identify what is termed a truth direction within the model's high-dimensional activation space. This is, in effect, a geometric vector that can linearly separate representations of true statements from those of false ones. It suggests that truthfulness may be an emergent structural property of the network that becomes more pronounced as the models scale.
Other research using a method called local intrinsic dimension analysis lends support to this geometric interpretation of truth. It was found that when a model generates a factually correct response, its internal activations are structured and compact. They exhibit a lower dimensionality. Conversely, when the model hallucinates or fabricates information, that internal activity becomes diffuse and chaotic. It exhibits higher dimensionality. This is a significant finding, as it implies we might one day be able to assess a model's truthfulness by observing its internal state without having to cross-reference its output against an external database.
The proposed right to be remembered also finds itself in direct opposition to an established legal concept, the right to erasure, more commonly known as the right to be forgotten. This creates a notable legal and philosophical conflict that must be addressed.
If we compare them directly, the conflicting principles become apparent. The RTBR is concerned with collective knowledge and historical accuracy. Its goal is to preserve a complete digital record, justified by a societal duty. The right to erasure, on the other hand, as codified in GDPR's Article 17, is focused on individual privacy and autonomy. Its goal is to give people control over their digital footprint, justified as a protection from persistent data, primarily in the context of searchable commercial databases, a very different context from that of foundational AI models.
This conflict is compounded by technical realities. Within an LLM, knowledge isn't stored in discrete files. It's distributed across billions of interconnected parameters. Attempting to remove a single piece of information, a process known as machine unlearning, is not only computationally intensive, but also imperfect. More concerning is the risk that it could degrade the model's overall coherence, creating unpredictable deficits in its knowledge. As the paper memorably states, attempting to excise data this way is like performing a lobotomy on our repository of human knowledge.
The resolution to these challenges, then, is not likely to be a simple post hoc fix. Instead, it requires a fundamental shift in design philosophy. The preservation of memory needs to be treated as a core design imperative for the next generation of artificial intelligence.
This new paradigm would involve several concrete architectural changes. First, truthfulness must be an explicit design objective from the outset, not merely a desirable outcome. Second, systems need to be built with layered attribution and traceable provenance, so the origins of information remain transparent and accessible. Third, models should be engineered with mechanisms for uncertainty calibration, the ability to effectively communicate "I don't know" when a reliable answer can't be formulated. And finally, our legal frameworks will need to evolve to address the unique challenges of foundational models, striking a new balance between individual privacy and the societal need to preserve collective memory.
As artificial intelligence becomes an increasingly central gateway to knowledge, the integrity of its memory will, in many ways, define the integrity of our own. This leads us to the central challenge, which is ultimately a question of both design and values. How do we build infrastructures of memory that ensure progress does not proceed by way of forgetting?